Question bank. Question bank. So this question bank will have short questions as well as it will have long questions. Okay. So let me change the color. Okay. So unit 1. Okay. Let us talk about short questions. Okay. So the first short question can be question number 1. What do you understand? Understand by the term indeterminacy. Okay, this can be first question. Second, what is meant by the term TERM? What is meant by the term statically determinate and statically indeterminate? Okay. Next, the third question. Third question is why? Because I'll erase these questions and I will go for a new. When a structure is said to be externally indeterminate. Similar question. When a structure is said to be internally indeterminate. Okay. Next. Next question will be, what is the formula to calculate the external indeterminacy external indeterminacy of continuous beam, B, pin jointed truss, C, rigid jointed frame. Okay, these are some of the 6 questions. Okay, still many more questions are there, so please stay tuned. Next page, I'll go to next page. Question number 7. Determine the degree of static indeterminacy of the following structures. Okay, now what are those structures? The first one is, sorry, this is the first one. ठीक है, कबट्टा दे दलो मोरो. Okay, the second structure is this one. The third structure is this one. The fourth structure is these are all short questions. These are not long questions. These are short questions. So this can be asked as one question. This can be asked as one question. This can be asked, even this can be asked as one question. Okay. So since the question for each of the figures will be same, so I am telling about all the structures here. Okay. These can be your questions, or these can be asked in questions. Okay. Next structure can be like this. We have a frame over here. This is roller joint, and this one is hinged. Another structure can be like this. Okay, so this is the structure, and here we have one external force. Let us say it is M. This is A, this is B, this is C. Okay. Similarly, the other structures can be like this. So other structures are okay, this is A, this is O, this is B. So you have to determine the static indeterminacy. Okay, similarly, one more structure can be like this. Okay, another structure can be like this. Both are hinged. Okay, another structure may be like this. Now this is a roller and this is a fixed one. Another structure can be like this. This is fixed, this is hinged, and this is, let's say, a roller. Okay, now, so this is your seventh question. The eighth question can be question number 8. What do you understand?
Sir, sir,
Yes,
sir, can you, uh,
yes,
sir, I can't write, sir, that one. Last question, sir.
please write it fast.
Yes, sir, completed, sir.
Okay. So the eighth question, this is short question. I'm talking. These are all short questions. Okay, these are all short questions. So next question is, what do you understand by the term internal redundancy of a structure? Okay. Question number 9. Write the formulas or write the expressions for the or expressions to determine the internal redundancy of the following structures. Okay, so the first one is A. It is a continuous beam. The second one is a truss. The third one is a frame. Okay, next question. This is our question number 10. What do you understand by the term total static indeterminacy of a structure. Okay. So the next question can be determine the total static indeterminacy of the following structures. Now, what are the structures? The first structure is this one, the frame. Okay. Next, we have a truss of here. Okay. The next structure is like this. Okay. The next structure is this one. This is hinged. This is hinged. This one is also hinged. This one is also hinged. This one is also hinged. Okay. Next, this one. Another problem is this one. Okay. So these are some of the questions which you should know. Okay. So this is all about the static and determinacy part. So next one is this is question number 11, question number 12. So the question number 12 is, what do you understand what do you understand by the term kinematic indeterminacy of a structure. Okay. Question number 13. Write the formulas to determine the kinematic indeterminacy of the following structure in 2D and 3D. So the first one is a pin jointed frame. B, a rigid jointed frame. Okay. Next question. Determine the kinematic indeterminacy
Sir,
of
wait for 1 minute, sir. I am writing 13th question, sir. What you are writing, it is coming too late, sir.
too late.
Yes, sir.
Why?
Yes, sir.
Okay, one more thing, guys. See, just a moment. Yes, I think I have put the class on recording. Okay, so if I'm not mistaken, yes, I'm recording this one. Okay, so don't worry if you missed somewhere. Okay, you can watch this the video. Okay, don't worry. Because I'm recording this one, so I'll upload this one in YouTube. No need to worry. You can yeah, get this one. Here you just understand, or you just make yourself mentally prepare to solve these kind of questions. Okay, this will take a lot of time. Okay, I've just started discussing unit one. Okay, so in order to discuss questions for all the units, it will take some time. So don't worry, you just stay focused. Okay. So this next question is determine the kinematic indeterminacy of. Can you hear my voice?
Yes, sir.
Yes,
Okay.
sir.
Okay. Determine the kinematic indeterminacy of the structures shown in the figure below. Okay, so now what are those structures? So those structures can be like this. Okay, Next one, the next structure can be like this. Okay, another structure can be like this. Okay, next structure can be like this. Okay, uh, another structure can be like this. Another structure can be like this. Okay, next question, that is the 15th question. What do you understand by the word degrees of freedom of a structure? Okay, right. So these are all the short questions which you can expect from unit 1. Okay, so next we will go to the long questions. Long questions. Okay, so in long questions, you can be asked as so question 1. Sorry. Question 1. Okay. Analyze the frame shown in the figure below. Below, using the principles of least work. Okay. Also draw the shear force and bending moment diagram.
Sir, the principles of least after least, what is that word, sir? I didn't
Least
understand that.
WRK, principles of least work.
Oh, thank you, sir.
Okay, so this is the structure. This one is a roller. This is fixed. And here we have a point load of magnitude P, and the length is this one. This is L. This is of length L by 2, and this is 2I, and this is also 2I. Okay, so next question, question number 2. Using principles of least work, using principles of least work, find the reactions for the propped cantilever beam as shown in the figure. Below. So this is A, this is B. Here we have a point load. This is 20 kilonewton. Okay, and here we have a UDL of magnitude 20 kilonewton per meter, and the length of this one is 8 meters. Okay, so next question is, a continuous beam of length L is supported or a continuous beam sorry, is shown in the figure below. It has a UDL of magnitude W per meter length. Okay, over the whole span. Determine the reactions at the supports using the principles of least work. Okay, so how the structure looks like? The structure looks like this. So here we have one support, here we have another support, here we have another support, and this one is a UDL. This is W per meter length. This is W per meter length, this is A, this is B, and this is C. Okay, so next question will be next question. Question number 4. What is question number 4? Question number 4 is compute the reactions. Compute the reactions at A or compute the reactions for the beam shown in the figure below. Using the strain energy method. Okay, so this is the problem. This is 20 tons. This end is fixed. This is B. This is A. This is C. And this distance is, let's say, 100 centimeters, and this one is 500 centimeters. Okay. So the next question is question number 5. Evaluate the reactions for the portal frame as shown in the figure below. Okay, so now, and this is also using the strain energy method. Okay, so what is that method? It is like this. Sorry, the supports are hinged, or let us say the supports are fixed. Okay, this is, we have a load here. This is having 500 centimeter, 500 it is, 500 centimeter. This is 100 cm. This is 20 tons. This one is 600 cm, and this is I, this is I, this is 2I. Okay. Next one. Next question. Okay, so another wait. Another class it will be. So it will take another half class, okay, or we will dedicate another next 2 classes to discuss the questions for unit 1. Okay, another 1 class for unit 1, then we will continue the unit 4 problem. Then after some days again we will go to unit 3 and 4, and we will I'll give you the question bank. Okay, this question bank you can follow for your mid as well as end exams also. Okay, so
Okay, sir.
okay, so I'm stopping this recording now.